In this section, we are going to discuss about layout of thermal power plant and cold handling. This is the typical layout of a thermal power plant, and in a thermal power plant, the fuel is coal. So I am sending coal to the boiler. In a boiler, the combustion will happen in a boiler, and combustion requires a air, fuel. So here fuel is coal I am sending to inside, and hot air I am sending inside. So for a combustion we are supplying fuel as well as air. Then combustion will happen. So in a combustion reaction we need to convert that heat to the steam. So I am sending here water to the boiler. So it is converted to steam. Here the output of a boiler is steam as well as flue gases. Flue gas is nothing but a smoke in a combustion reaction. If you fire a piece of wood outside, that smoke is also having some heat outside while it is passing away. It is also having some heat, and uselessly it is going to the atmosphere. In the same way, flow, if I allow this flue gas to go outside of power plant, then there will be a lot of heat loss to the atmosphere. So efficiency will be very, very less. So what I am doing is here, after output of boiler is steam as well as flue gases. With these flue gases, I am sending these flue gases via superheater, economizer, and air preheater. The steam which comes immediately after boiler is having a water particles, so that is not having enough capable energy to generate a steam. So I am passing these flue gases through superheater. Then the steam comes from boiler will be again heated. That is called as superheated steam, so that it gains its full energy, and it will be giving lot of energy in turbine. So after that, after passing superheater, the same flue gases I am sending through economizer. Economizer is a unit where we are sending water into the boiler. So I am sending once I am sending these flue gases through economizer, the water will be heated and hot water will be sent to the boiler. And same flue gases again I am sending to air preheater. In air preheater, we are sending in air we are required air for combustion reaction. So this air, hot air, we are sending to the boiler. So this air which is we are forcing inside to the boiler will be converted to hot air, and then these flue gases will be transferred to here. One block is missing here, that is electrostatic precipitator. So here in these flue gases, we are in the flue gases a lot of fly ash will be present. So in electrostatic precipitator, this fly ash will be removed, and then induction fan, and then chimney. Out of chimney, we are disposing the flue gases. So the flue gas temperature here in the boiler is very high, and when it reaches to chimney, the temperature will be lost because we are extracting or we are trapping that energy in superheater to heat steam, as well as economizer to heat water, as well as air preheater to heat air. So it will reach outside. Once it reaches chimney, it will lose its, even it is having temperature, but it will lose its maximum energy. So here forced draft fan is used to pump air into the boiler through air preheater. And then this superheater steam once strikes the turbine, turbine will be rotated. So this kinetic energy is converted to mechanical energy, and then this mechanical energy is converted to electrical energy through alternator, or you can call it as a generator. And then this steam which is after striking turbine, the steam is called as exhaust steam, and it comes to condenser. It is the unit where condenser is an unit where this steam is converted to water, hot water. What we are doing is we are circulating a water, normal water, to the condenser, so that the energy present in steam is transferred to this water, and then this once this energy there in exhaust steam is transferred to water, this water becomes hot, and this steam becomes hot water. So here condensate extraction from here, the water will be hot water, and then we are sending recycling same water to the boiler via economizer. So the cycle will repeats, and then Here 100% of water requirement out of once it reaches to condenser, it will lose around 5 to 10% of water. So the extra 10 to 5 to 10% of water we need to supply from here. This water treatment chamber we have to supply here. So for each and every cycle it will lose some water, so that water we need to supply continuously. In a condenser unit, we are converting exhaust steam to hot water, and then this cooling water, once we are sending to cooling tower to condenser, this water becomes hot, and this water again we are bringing here to cooling tower. In cooling tower are big structures where this hot water we are cooling, and again we are recycling to condenser. And also in condenser also there will be a loss, then we are continuously taking water from river or canal. And here cold storage, cold handling. After cold handling, after combustion reaction, what happens is lot of bottom ash will be there. Bottom ash and fly ash. We'll divide ash into two types that we'll discuss in the next section. Bottom ash and fly ash. Here in combustion chamber, what is the ash remained in the down of the combustion chamber is called as bottom ash, and bottom ash will be collected directly from the boiler, as well as through flue gases fly ash will be transferred. And I said to you, as I discussed in the starting of the video, that here electrostatic precipitator where fly ash will be removed, and that also removed and taken outside of the plant, and we have to dispose that thing. This is the typical layout of thermal power plant. And then coal handling. Here first unit is coal handling. Before sending into boiler, we need to handle the coal, like crushing and everything we have to do before entering into boiler. So this is the coal what we receive from coal mines. Coal mines are pithead, sometimes we call it as pithead. And once we are transferring coal from there to power plant through via railways, as I said to you. And once it comes inside the power plant, rail sides means after the track, both the sides we have some space, so that is called as rail space. There we will unload through, we have two means we can unload the coal, that is grab buckets and cranes and wagon triplers. These are all like we can hold total wagon, and they will reverse the wagon. Very large cranes will be there, so they will hold the wagon, and they will reverse the wagon, so that all the coal which is there in the wagon will be come out of wagon. So then they will be sent through belt conveyors, and then through belt conveyors the coal will be transferred to bunkers. They will sold as storage units. There are two types of storage called as dead storage as well as live storage. Dead storage means directly the coal which comes after unloading and through belt conveyors, it will comes to dead storage. Means all next 40 days, we don't know what will happen in the next 10 or 20 days. Like corona, transportation will be stopped. So this, as it is an emergency service to supply a power, always will store coal for 40 next 40 days. So what we'll do is next 40 days coal will be sent to the dead storage. In a dead storage, again for the power next 8 hours, the power generation, for power generation, what is the coal required, that will be there in live storage. There are two units physically, it may be a same unit, but we'll call it as dead storage as well as live storage. In live storage, next 8 hours generation, what is the fuel required, that will be stored in live storage. It will be a continuous process. Then in a live storage, we'll send the coal to coal handling plant, because in coming next 1 or 2 hours, what we are doing is we are going to generate a power. So what I will do is, from a live storage, I will take the coal to coal handling plant where crushers will be present. So the coal, raw coal which comes from coal mines, they don't have proper uniform size. So what we'll do is, to make it proper size, we'll do a crushing, and through crushers, and we'll make into a uniform size of coal pieces. So then we'll go for, if any unnecessary material is there other than coal, like metals, small metals, then the magnetic separators will be there. So metals are removed in that section, and then it will go to drying and hot drying with hot air. where moisture, you know about water content in inside a coal or piece of wood, some wetness will be there that we can remove because we are taking from earth. Definitely, it consists of some moisture. So we need to remove that moisture. What we can do, we can dry with hot air. Then definitely the moisture will be disappeared. Then we'll send that dried coal to the pulverization mills or ball mills. We call it as ball mills. Here, pulverization is the process. You may listen or not. Just it's a process of making coal into fine powder. Means large particles into very small particles called as powder. We are converting, and because of that, what happens is more heating effect, less fuel consumption. Because if you burn a piece of wood and a piece of coal, I think pulverized powder of wood, which is completely dried, it is very easy. It will burn very easily. It will burn, but piece of wood burning and all, it will take much time, as well as inside part and all, whether it will burn or not, don't have surety. And also the energy release will be not good. So once we convert into pulverization form, convert into powder form, then the heating effect will be very high, as well as less fuel consumption will happen. But the disadvantage of doing pulverization is cost is high, because we are pulverizing into powder. It requires a lot of energy to do it, so cost will be high. Cost is high, as well as once you burn a piece of wood, fly ash will be very less. Fly ash means the ash which goes through smoke. When you fire a piece of wood and you observe, after complete combustion, you'll see lot of ash in the land, and remaining part will be fly ash, and fly ash will be very small. But once we pulverize, we convert into powder, and if you combust, fly ash will be very very high. So more fly ash is produced. More fly ash is produced means more pollution. Okay, the fly ash will deposit into our respiratory organs, and definitely that will leads to a severe health damages. So therefore, pulverization gives a lot of advantages. So what we are doing is, we are doing pulverization, but that fly ash and all we are removing in electrostatic precipitator. And then in the final stage, after doing pulverization, we are sending coal to the boil furnace. In the boil furnace, what happens? In the boil furnace, a combustion process will happen, and finally, as a result of combustion, what will be the output? Steam, as well as flue gas, as well as fly ash, as well as bottom ash. Bottom ash will be very less in terms of when we consider pulverization process, and then fly ash will be there. And fly ash handling is difficult. We are doing it by electrostatic precipitator. The next section will discuss about complete layout and parts of thermal power.